Oh well, let's just get this started then. All right, moving on over. So what we're doing today, so by the end of this section, we're going to be able to graph linear inequalities and determine solution areas and apply graphing inequalities to solve real-world problems. Okay, so about linear inequalities, if you remember when we were talking about inequalities, a number can be either larger or smaller than where the solution begins. So like if x is greater than 5, certain numbers will make it true, others will make it false. So with this, it's the same thing, except now you're worried about two things, the x and the y. So it's similar to a linear equation, however, an inequality symbol is used instead. So if we have this inequality, I almost said equation, which is not entirely wrong, but it would be an inequality because equations have equal signs. Y is greater than or equal to negative 2x plus 9. Determine which points satisfy the inequality. So some of these will, again, make it true, others will make it not true. So let's go ahead and plug it in. So don't forget that each of your ordered pairs has an x and a y. And we're going to plug those in. So y is 4 greater than negative 2x. So negative 2 times 7 plus 9. Warm up that arm. Okay, and then keep going. Evaluate your inequality, negative 14 plus 9. And now we need to add these together. So 4 greater than, let's see, negative 14 plus 9, so that'd be negative 5. And is this true? Well, yeah, positive numbers are always greater than negative numbers. So this is a, yes, this is a solution. So that this ordered pair fills this into a workable solution. Now let's go ahead and do the next one. So I'm going to plug in, again, we have our x and our y, and we don't need to do this every single time. As long as you know where to put the y and the x, negative 2, and it's the same one, we're just using different numbers, same equation, different numbers. Okay, negative 2, so that'd be negative times negative is positive, anything times 1 is going to be the same. And in this case here, I get 3 is greater than or equal to 11, which is false. 11 is, it should be the greater one, not 3. So this is a no, this is not a solution. This is not going to work with this inequality. And let's just do one more. So negative 5 is greater than or equal to negative 2 times 10 plus 9. So negative 5 greater than, and then multiply these together so we get negative 20 and add 9. Now this looks like it's already going to work, but let's just make sure. Negative 11, because since they're different, they're going to oppose each other. And since the negative is bigger, it's like they're kind of pulling on each other, and the negative is bigger, so it's going to pull the answer into the negative. And this one is true because if they are both negative, we want the one that is less bad, I guess. If you're thinking about two things that are bad, you want the one that is less bad. Okay, so if you have to go, if you have to go to two options and they're both kind of bad, like would you rather go to, I don't know, Cardi B or Justin Bieber concert? You know, they're both bad, but you got to pick one of them. Nah, I'm kidding. I've actually never listened to either of them. I'm just picking on them because it's popular to pick on them. All right, so let's go ahead and look at a real world example. So John sells t-shirts. Plain shirts are $5 and graphic shirts are $7. In order to match his product cost, he must make at least 12 well, I would say 1,200, but 1,200 is the other way you would say it too. Which is kind of weird because, like, I mean, I know a lot of people say 1,200, but it's always kind of bugged me that 1,200 and 1,200 are easily, you know, the same number, but pronounced very differently. Anyway, write an inequality to represent this situation. So we'll just go ahead and use P for plain shirt. So 5P. So again, if he sells one plain shirt, it's $5. He sells two, that's 10. 3 is 15, right? And he's selling them in combination. So there's like different ones. So the other one is graphic. So graphic is G, so 7G. And again, that stands for, you know, printing a design on it, kind of graphic, not the other kind of graphic. Anyway, so if he sells one, it's going to be $7, two is $14, three is $21, and so on. And in this case here, it says he needs to make at least $1,200. And there I go, pronouncing it like that again. Now, when you, there is a list of which inequality keywords mean what. And that's kind of a, I mean, I wish I could go over it, but I don't know if we're gonna have time today, maybe on Wednesday on the half a day. But when you say at least, that's the lowest amount that you can go, right? So like, for instance, in order to get a driver's license, or actually, let me back up a bit. To get a learner's permit, you must be at least 15 years old, right? You can't get one if you are 14 or 13. It at least means that you have to be that age or higher. So that means this side has to be higher. So if these numbers, if we plug in a P and a G so that we get, say, 1,500, in that case, yes, he does make up his cost for the products. What they oftentimes call the break-even point. Now, if he sells exactly $1,200 in shirts, then again, that's what you call breaking even. But in this case here, we don't want to break even. He wants to make profit. So it says here, if he sells 150 plain shirts and 60 graphic shirts, will he be able to cover his product cost? So let's go ahead and plug that in. So 5 times 150, because that's how many he sold. And 7 times 60, because he sold 60 of these shirts. And we got to ask ourselves, not equal, we got to ask ourselves, is this going to be greater than 1,200? All right, so 5 times 150, and that'll be 750, plus 6 times 7 is 42, so I'm guessing that's going to be 420, which it is. All right, if you're laughing, grow up. All right, and add that to 750. And let's see, we got one more step. I already added them, so let's see what we got. We got 1170 greater than 1,200, which in this case, the answer is no, he does not make up his cost because he did not sell enough shirts in order to, you know, pay for all of his the cost of running business, because having a business, you have to consider what it costs to run it, not just how much money it brings in. A lot of places like Burger King, you know, you might think, wow, that place makes a lot of money, but really they spend a lot to get it there, you know. Like if a new Burger King opens in town, it'll take a couple of years. I think it takes like 10 years in order for them to pay off the cost of the building or something like that. But even then, there's all this stuff about interest, and the bank wants their share, so it's not really gonna work out for a while. And that's just how business is done. If he sells 90 graphic shirts, what is the minimum number of plain shirts he must sell to break even? All right, so right now he sold 90 graphic shirts. So 7 is the number that we need to pair with 90. All right, so let's see. 7 times 90, which I'm pretty sure is just 7 times 9, which is 63, so it'd be 630. All right, so there's $630. That was definitely that we definitely have, right? We can be sure of that much. Maybe somebody before he set up, wanted 90 shirts of a design logo on there. Maybe it was, I don't know. Maybe it was a shirt that said Poggers. That actually sounds like a really cool shirt. I'd get one. And maybe it has like an anime person's face on there. Anyway, so we got to find out. All right, so we're gonna subtract the cost because we already had $630 already pretty much guaranteed from this order. So that means that we have $630 less to worry about. So let me go ahead and get that. Let's see, 1,200 minus 630, so it'd be 570. And now I have to divide that by, it's supposed to be 570. That 0 looks kind of off, so let me just fix that. And I'm going to divide that by 5. And this means plain shirts, the number of plain shirts has to be greater than $114. 114 plain shirts. That's how much more we need. We need $570 worth of plain shirts to make up for this cost. And we would need about 114 in the number of shirts in order to break even with that. All right. Let's go ahead and keep going. So graphing them, now we need to learn how to graph them. So you pretty much do the exact same thing. If you remember graphing just regular lines like slope-intercept form and standard form, pretty much the exact same thing. And here it says to put it in slope-intercept form, make sure to flip the inequality if you multiply or divide by a negative. So on week, I think it was like week 4. I think it was week 4 and 5. Okay, so it's about week 5. Remember, we did the thing where if you divide both sides by a negative, you got to flip the inequality sign, the direction that the mouth is going. And then we have to graph the line. Now, this is a little bit different. We're not just pointing in the direction that the line, the solution is. We're actually going to have to do a little bit more than that. But we also have to use a dash line for less than and greater than, and a solid line for the less than or equal to and greater than or equal to symbols. So it's kind of like the hollow circle and the filled circle, or as they call it, the opened circle and closed circles. It's the same thing. So you need to have different kinds of lines for different kinds of the inequality parts. And then shade of shade above the line for greater than symbol or greater than or equal to symbol, and below the line for less than or less than or equal to symbols. Now for this one here, I would also just tell you, just pick a point and test it. Just pick a point and test it. And just like if you remember when we were doing the other ones, like 0 was a pretty good one because 0 rarely fell in the middle, or I'm sorry, 0 is always in the middle, and it was almost never the number that you picked. So 0, 0 is a pretty good one for this one. All right, so let's go ahead and move on to the first one. So first thing we got to do, it's already in slope-intercept form, so that's taken care of for us. So let's go ahead and mark out the line. So I'm going to go ahead and mark out -1 right there. And I'm going to need a dash line. And remember, we need a straight line And it's got to go all the way from one side of the graph to the other side of the graph for as long as we can see what's on the graph. So starting at -1, remember, I always have that thing, yesterday I made excellent breakfast. So always start your day with breakfast when you can, of course. Not like me today. So follow your rise and your run. So rise over run. So up 2 over 3, up 2 over 3, up 2 over 3. So again, go all the way to the edges of the graph. And then I need to do the same thing on this side. Let's see, up 2 over 3. There we go. So there's my dashed line. Now I'm going to need to shade it. So if you remember what it was saying, it says that if it's the greater than symbol, we shade the upside. And that's if it's greater than. This is not greater than. This is less than. So the mouth is facing away from the Y. So an easy way to remember this is Y-axis, right here. See where the Y is on top? Most graphs have a Y on the top. Some of them might have a Y on the bottom, but that's kind of rare. So if it has a Y on the if the mouth is open towards the Y, it's going up towards this Y. If the mouth is away from the Y, that means it's going down. I don't know if that's an easy way to remember it. But that's just sort of the way I know most graphs are. So again, Y means, again, up and down. So this means I have to shade it as close about as I can get it. So there we go. And that's it for that one. Now that's pretty easy. I can see all the area below the line fairly easily. Now let's go ahead and do this next one here. So Y is greater than or equal to -4x. Where is the B value, the Y-intercept? Well, what do you do if there is none? Does that mean there's no line? It means there is a line. We just have to start from 0. Okay, we just got to start from 0. So in this case here, go right to the middle because it would be -4x plus 0. Mathematically, it's the same thing. And follow the slope. But wait a minute, this slope is not a fraction. Now, you can also turn it into a fraction by putting a line and a 1 under it. So turn it into a fraction by -4 over 1. So that means down 4 over 1, down 4 over 1. Now I'm going to have to go back up this way here and go up 4 over 1, up 4 over 1. Let me just move that line a little bit different. Now this line is very steep. Okay, it's pointing very close to the up and down areas, but it is still with a bottom area and a top area. So the mouth is open towards the Y. So if it's open towards the Y, that means, again, you think of it as towards this Y up here, or Y can also just mean like the up in general. All right, and I'm just going to use this here to fill it in with. Oh, and I almost forgot to mention that this has the or equal to, so you treat it like a closed circle. And it means that you can pick areas on the line. So that's why we use the solid line. Like if I were to pick the points, -1, 4. So X is -1 and Y is 4. So again, that would be like right here. And you don't need to do this every single time, but I'm just showing you that if you pick an area right on the line and you plug that point in using its X and Y coordinates, you will get a true statement. In this case, negative times negative is positive, and 4 is equal to 4. So it makes it true when it's 4 is less than, or in this case, greater than, or equal to 4. So that's a true statement. If I did the same thing with this one here and I pick an area that follows right on the line, Just as an example, if I were to pick 2, all right, so x equals 2, you know, I don't know if it's exactly what it'll come out to, but it would probably come out to something like this, which is false because there is no or equal to. 2 is not less than 2, and I don't have the option of or equal to, so that's not going to work out. So that's why we have the dotted line and the dashed line. All right, so in this case here, we could graph this using standard form, but actually that's probably not going to work out all that well, because if I divide 12 by 5, I get something like 2.2 or something like that, or 2.4. So I think we're going to have to turn this into a slope-intercept form problem. So minus 5x from both sides. So I get 3y is less than or equal to, now x has to go first because that's just the way slope-intercept form is. So I'm going to put the minus 5x plus 12. Now I need to divide everything by 3. So y is less than, and I'm just divide everything by 3, divide that by 3, and I need the x also. And divide this by 3. So 4 divided by 3, sorry, 12 divided by 3 is 4. And anyway, there we go. So now we have all the pieces to the graph. So let me go ahead and mark 4 on the graph. And now I need to put the line on there. Now I needed to choose the right kind of line, which this one is a solid line because of the or equal to. So again, make sure you choose the right line. So down 5 over 3. So let's see, down 5 over 3. So it has to go through that area, down 5 over 3. We'll go ahead and move this back up here. There we go, down 5 over 3. Now we have to shade it. And again, probably the easiest thing to do, in my opinion, is to plug in 0, 0. As long as your graph is not going right through the middle like number 2 did, you should be able to pick 0, 0. So 0 is less than 4, which is true. Or again, 2, you can also look at the mouth and notice that it's facing away from the y. If it is facing away from the y, that means the downside is shaded because we don't want the y on the top. There we go. So everything below the line is shaded, and all lines have an above and below area as well. I mean, it's, I don't know. Like I was talking about this line being steep, that's still above the line. I mean, you can kind of imagine like if there's rain and it comes and it hits this roof, it's going to kind of go down that way. You know, and if you're looking at this area below the line, you can think of it as like shade, right? Because everything below the covered area is shaded. I never knew that the shade and the had those two meanings. Anyway, let's go ahead and do this one here. So I need to, again, put this into slope-intercept form. So minus x from both sides. And that gives me negative 6y. And less than negative x plus 12. Now I'm going to need to get rid of this negative 6. And again, this is the thing you got to worry about. You got to watch out for this, not worry about it. I mean, like, don't get stressed about it like anything that you would get stressed about. But again, be vigilant for this one because this is the thing that you really got to watch out for because that was one of the rules. If you multiply or divide everything by a negative, then you also have to flip this inequality sign. So y is greater than now. 16x minus 2, because it's a negative. Or, oh, wait a minute. No, I switched it before. I don't know. I kind of knew it was supposed to be that, but somehow I missed it. I must have just not have written it. Because it's supposed to be a minus here, but somehow when I wrote it here, I must have mentally already taken the negative out. In the meanwhile, it looks like we're done with that one. Let's go ahead and mark out 2. And then follow the slope, so up 1 over 6. So I just got to draw a line between those 2 dots. Now I need to pick the kind of line that I need. In this case, I will need a dashed line because there is no or equal to, so that means I cannot pick something that lands directly on the line. That's weird. Like some kind of weird dot there. Anyway, so down 1, back 6, and it looks like we crossed that area too, so close enough. And again, make sure your line goes all the way from one edge to the other edge. Now in this case, y is the greater one, so the mouth is open towards the y in our function. All right, let me try it instead. And you just need to shade this area in with your pencil or whatever you have. Pens don't make a very good shading tool. So there we go. The top is shaded because the mouth is opening towards the Y. And I think that's it for this one here. We are pretty much done with this. So let's move on to questions number 5 and 6. Okay, another one that is not in standard form. So if it's not in standard form, it looks like we're going to have to put it into standard form. So I'm going to get rid of this 9x, so minus 9x from both sides. So now I only have 12, y greater than negative 9x minus 60. Still got to divide everything by 12. I got to get rid of that 12. So divide everything by 12. And I'd like to, normally I know most teachers would write a line and put everything with 12. But I'm going to save myself a little bit of space. And here I end up with 9 over 12. And as I always say, anytime you run into a fraction, you should always ask yourself, can you divide it? And if not, can you reduce it? So 9 over 12, both 9 and 12 can be divided by 3. So that's what we're going to do. We're going to go ahead and divide this by 3 and divide this by 3. Minus, and then 60 divided by 12, it's going to be 5. There we go. So now we have our line in slope-intercept form. All right, so I'm going to go ahead and move down 5. And let's see, we are going to need a solid line because this one has the or equal to. And our line has a negative slope, so that means it's going to be going down from left to right. So down 3 over 4. So it looks like right about there. There we go. Now we have to find out which side to shade. So the mouth is open towards the Y. So that means we shade the side towards the Y. And above the line means like, again, kind of like rainfall. You imagine rain going on the roof, it's going to hit and just sort of slide off, and anything under there is going to be safe from the rain. So now we just got to shade this area up here. And there we go. That's it for that one. Okay, so now we got to do the next one. This one's missing one of the variables, right? It's missing one of the, it's missing the y in this case. So remember what I always say, when something is missing one of the numbers or one of the variables, it means it's not going to touch that axis. So if we go to the x on the x-axis, because remember this is the x-axis here, we go to -4, so 1, 2, 3, 4, so that's -4. And here's kind of an interesting thing. Remember how when we were drawing the arrows on to tell you which way the answer was? It's going to be the exact same thing here, because it says here x is less than -4. So that means the arrow is going to point that way. All right, but we're not drawing arrows. We are trying to get this area shaded. But it is still going to be everything on that side. Well, this side for you, looking at it here. So I'm going to draw my straight vertical line that goes straight up and down. There we go. So again, it does not touch the y-axis because it is parallel to the y-axis. And we already showed that the arrow is going to point that way. So that's the side that it's going to have to be shaded on. Yeah. There we go. Just like that. Okay. All right, so let's go ahead and okay, that wasn't too bad. We're actually making pretty good time. But again, most of this is kind of things that you might already know, because graphing lines and turning things into slope-intercept, those are all things we've already done before. Graphing, again, you know, where the line begins and where it goes. It's all kind of stuff you've already known. And we've also covered graphing not too long ago, like I said, like a week ago. But well, maybe not a week ago, like a week or two ago. But even then, it's not so long ago that you would have forgotten everything. But again, the only two new things that you really need to remember is which side to shade and what kind of line to use. All right, so this is kind of an older word problem. Stephanie spends 10 cents per text message and sends 25 cents per picture message sent on her cell phone. Her monthly budget for messaging is $30. So write a linear inequality to represent this and then graph it. All right, so let's go ahead and just put 10x plus, well, actually that'd be 0.10 plus 0.25y. And it has to be under that amount, right? So that means that this is going to go this way. Now, is there going to be an or equal to? Well, let's think about it this way. Let's say the math worked out and she managed to get exactly $30. Would that still fit in her budget? Yeah, because if she manages to get exactly $30, let's say that, let's just say that the plan already has $30 included in there for that, right? So if that happens, then if she manages to get exactly $30, she doesn't have any left over at the end of the month, and she doesn't have any over, right? It's not over and it's not under. So it's like, it would, I guess that would actually be an ideal. And this is like a long time ago. This is like 2012 time period of how phones were charged. I think more people nowadays have the unlimited text and talk. Anyway, so it's got to be under $30. So that's why we have this facing towards the 30, not because that one's the greater number, because it should be the greater number. All right, so there we go. And then graph it. All right, so graphing this. Oh no. 0.25y. And it looks like I'm gonna have to minus 10 cents from both sides. So all I did was minus 10 here, minus 10 here. So that's why it's on this side now. And since I am trying to solve it, I'm trying to put it into y equals mx plus b, so I'm trying to solve it for y. Now I need to divide everything by 25. All right, so divide 10 cents by 25 cents, so that'd be 10 over 25. And let me just go ahead and turn that into a fraction. Now, this is kind of a tricky one, because if they are both decimal numbers, 0.10, 0.25, if you're going to turn them into a fraction, you cannot have fractions and decimals in the same number. That's one of those big things about math that very few people know about. All right, but now you're learning it today, because any standard number, any number that is going to be used anywhere, cannot have fractions and decimals together. So all I did was multiply both top and bottom by 100 to get rid of that, decimal. Now I'm going to go ahead and simplify it like I do. So 10 and 25 can both be divided by 5. So 10 divided by 5, 25 divided by 5. And that will reduce that. So now we have 2/5 x. Now in this case I ignored the negative just to work with here, but that would be a negative 2/5 x. Now I have to take 30 and divide that by 0.25. 30 divided by 0.25. I'm going to just use my calculator for this one, and we get 120. I said 120. All right, so there we go. Now we just need to mark out an area on the graph. That would be 120. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, okay, there we go. We got it right on. So each of those marks is going to be 10. So that means this is 20, this is 40, 60, 80, 100. There we go. And same is going to be on this axis as well. So it says to graph it. Now again, because there is the or equal to, because it is possible for her to manage to get right on the line and still be within the budget, let's go ahead and graph it. So that's down 2 over 5. And there we go. So, well, might as well, while I'm at it, draw these marks here. 60, 80, 100, 120. And I'm not sure if those will really perfectly line up, but just really to give us an idea of what's going on. All right, there we go. So we graphed it and we wrote it into slope-intercept form, and we wrote the inequality. So A is done. Using your graph, give 2 possible combinations of text and picture messages that she can send and stay within her budget. So in this case here, we got the area that we want to be in is going to be below the line. Now, I also just managed to switch this to, there we go. We didn't do anything to switch it, so it should still be the same. So we want to be in this area below the line. That's the area we want to be in. So again, the shaded area is where the solutions are. That's what we call the solution area. I call it the solution area. Because in algebra, usually you only have one solution, but in this case, we can pick anything. We can pick anything under this line. And I think and if people are going to send messages nowadays with pictures, I think they would rather use something else like Pinterest or Snapchat or what are some of those other ones? But I know there's a lot of ones that just share pictures. Anyway, so let's see, give 2 possible combinations and that she can use to stay within her budget. All right, so, excuse me. All right, so I'm gonna label them just because I wanna make sure I get them right. So let's say that she's gonna send 100 texts. What's the maximum amount that she could send and still get? All right, so let's see, text would be 100 and pictures would be 80. I'm just gonna clean these up a little bit. So that's one combination that she could use. And then there's the combination 2. Let's say that she wants to send more pictures. So if she's sending, well, she could also send something that's well below the line. That thing's like 30 minutes early today. Now, where was I? We could also just pick something like here. All right, and that's perfectly fine also. If she wanted to, she could send 40 texts and 80 pictures. There we go. So it doesn't have to be on the line. It can be anywhere below the line, anything. All right, so anything, like literally you have like 100 different possible answers for this one here. But as long as that area is underneath the line in this shaded area, because if she goes anywhere over this area, like even this place here, she's gonna go over budget. So if she manages to send 110 texts and 80 pictures, yeah, that's over. Even if it's only by like $1 or a few cents even, it's still gonna be over budget. And the way some places charge for data, that's no joke. All right, so that's it for this one. All right, so Scott makes $12 an hour babysitting and $8 an hour at the grocery store. He will need to make at least $600 to buy a new computer, hopefully gaming PC with the latest graphics card. That's what I need. Actually, I have one, but I never use it. I don't use it because my brother took it. And I'm debating whether I want the PS5 or the, what's the Xbox one called? Not the Xbox One, but the new Xbox. Anyway, I'm not really excited about the Xbox option. I'm gonna go with the PlayStation this time. I've been an Xbox for like the past 2 generations. Time for me to go back to my roots. Anyway, write a linear inequality to represent this situation and graph it. So let's just use X and Y again. So there's X and Y. So X will be babysitting, and Y will be the other thing, store. So we got to define our variables, which I did not do on the last one. But that's okay though, learn from my examples. Probably would have been easier to just type it out. Anyway, so $12 an hour babysitting. And grocery store is $8, so 8Y. So if he works at the grocery store for 3 hours, it'd be $24, and you get the idea. Now, he will need to make at least $600. So this one here is another one of those keywords, and I think we've already used the word at least before. So when it says at least, that must mean that it's or equal to, right? So again, if you have to be at least something, right? If it were, let's say, you know, if you're going to go, let's say, gamble at the casino, you need to be at least 21 years old, right? If you're not 21, don't even try it. Although I don't condone gambling at all. It's like, I don't know. It plays on a lot of human mentality and human fallacies that their brain has that kind of makes them think, oh, I'm going to win, but they never do. The best way to win at gambling is to not play. Unless it's the lottery. But then that one, don't play it either. Okay, so it looks like we got that done. So again, this side has to be greater than 600. So even if he gets like $700, he still is able to buy the computer and he gets a little bit of leftover money. So this is the side that we want to have be bigger. Okay, looks right. Let's go ahead and graph this one. So let's see. I'm going to minus 12x from both sides. So 8y greater than negative 12x, because I minus 12x from both sides. And it cancels this one, and it comes over here as negative 12x. And I'm going to put the, I could say 600 minus 12x, but I want to put it into y equals mx plus b. I want to have that slope-intercept form. There we go. Now I got to divide everything by 8, so I don't have a whole lot of room to write in here. So y is greater than, and I did not divide by a negative, so I don't need to flip this sign, but remember, that is something you got to watch out for. Even though this number is negative, we're not concerned about numbers that are being divided. The only numbers that we are concerned with is the numbers that we are dividing with. All right, so 12 over 8. And now I can divide it. It would be like 1.5 or something like that, but we don't want that. If it's a slope, we want a fraction, not a mixed number, not a decimal, even though they do kind of work. So I'm going to go ahead and take 12 over 8, and let's go ahead and reduce that. So we need numbers that both 12 and 8 can be divided by, which in this case is going to be 4. So 12 divided by 4 is 3. And 8 divided by 4 is 2. Now, even if I were to take this and divide it, 3 divided by 2 would still be 1.5 or 1.5. But again, it's better to have fractions. So 3 over 2x plus, and again, we're not using any negatives, so I don't think this is going to change anything. 600 divided by 8, and that would be 75. There we go. Now what this is telling us is that we could, this guy could theoretically work 75 hours babysitting, and he would manage to get the computer, assuming, but then again, he also has to work at the grocery store, so that's not very likely that he'd work 75 hours babysitting and not being at the grocery store. But anyway, that's kind of what the y-intercept means. So let's see, What can I make these be? 10, 20, 30, 40, 50, 60, and 70. All right, so there were about, okay, so just judging by the number of markers, seemed likely that I was going to be there, so I guess I was right. Oh, you know what else I also seem to have lost out on too? I seem to have forgotten the negative, because once I was going to graph this, it would make no sense to have the graph go completely off. So if that ever happens, in this case here, I was so focused on reducing the fraction that I forgot to put the negative in there. But again, you got to check yourself. Don't be afraid to look at your work and say, is this okay? And let's go ahead and graph it. So I need to go down 3 over 2. Wait, is it down 3 over 2? Yeah, down 3 over 2. Down 3 over 2. Ah, there we go. I think, close enough. But again, in this case here, we want more than $600. Or again, looking at the mouth, it's open towards the Y. And since the mouth is open towards the Y, I'm going to go ahead and shade the area above the line. There we go. So this is the area that we want to be in. I'm going to just mark out my axis down here. Well, we would actually say axes, but sometimes that's just a bit weird sometimes. 10, 20, 30, 40, 50. I guess it would be about 50, 60, maybe 55. Okay. Then use your graph and give 2 possible combinations of the number of hours Scott can babysit and work in the grocery store to ensure that he can afford his new computer. Now for this one, I feel like working, I feel like having, now hold on a minute. I would say 40 hours a week, because 40 hours a week is very typical for grocery stores. But looking at how that 40 hours would only be about half of that amount, well, actually, I guess this is by week. It could be by week. So most jobs will not allow you to work 40 hours or more, because then they have to pay you overtime, and overtime usually means that they have to give you a little bit more money than you would normally get. So like if you get $10 an hour, which is what it is in Arizona right now, overtime would be $15 an hour. So you get slightly more hours, slightly more dollars per hour than you normally would. So a lot of times stores don't want people to work more than 40 hours. So let's go ahead and go with that. So let's go 40 hours. 40 hours babysitting, 40 at the store. Actually, well, 40Y. Now, if he works 40 hours at the grocery store, how much would he have to make to get that computer for 600 bucks? And let's just play it safe and say that he can do 30 hours. So 30x plus 40y is greater than 600. Oh no. Well, that would probably work out. But let's, oh man. All right, so I'm just gonna write it. How did we write it the last time? Oh, okay, we just wrote it out like that. Okay, so babysitting. Let's just go ahead and just write it like this. I'm gonna put, that would be 30. And store, all right, so I'm just gonna write store is 40 hours. And just to make sure, we could also plug it in. So $12 an hour babysitting, 12 times 30, and add that to 40 hours at the store for $40, $8, or sorry, 40 hours, 8 hours a piece. $8 an hour. Oh, getting tongue-tied. So 4 times 8 would be $320. So if he worked this combination, he would get $680 if he worked this particular combination. So that works out. But maybe because of COVID and the store might have limited hours, so they don't want to stay open all day or whatever, limit the number of hours that people are working. Maybe they're going to cut it down to 30 hours. And the babysitting, how much would he have to work then? So we could also look at the graph as well. So in this case, Y is the store. So if he had to work 30 hours at the store, he should work at least 35 hours to ensure that he can pay for the 35 hours babysitting to ensure that he would still get the $600 that he needs. And maybe he's not using it to buy a dope gaming PC. Maybe he's just needing to do work at home because of COVID now, everyone's at home and he has to go, and he has pretty good business doing babysitting because everyone still has to work and leave their kids at home to work on Zoom. Okay, this problem really hits close to home, but I'm gonna just check it really quick to make sure that using his babysitting and store, that he would still be able to afford this. So 35 times 12 would be 420. Store is store is $8 and 30 hours. So 8 times 3 would be 24. So that'd be $240. And that would be 600. This combination would yield $660, which is still good. You know, you also got to account for taxes as well. That's why I'm kind of going a little bit over the green line. All right, so there we go. There's a second part to this, but I'm not sure if we're gonna have enough time to go over the whole thing. We may just have to save that for tomorrow, although I don't really want to save it for tomorrow. I think we're gonna have to. I have, there's also the half day on Wednesday. This would have been really good to have had on Tuesday. That way the half a day, we could just use it to complete this one because there's only about 6 more graphs. Well, let's see, about 9 more graphs. But we're not gonna be able to finish it now. So we might have a bit of a shorter lesson tomorrow just because we just need to finish up this one here. Because this is where we're gonna start off tomorrow. I'll work something out. In the meanwhile, I guess that's it. That's it for today. Let me go ahead and take care of that really quick. And I'll be around for another minute or two if you have any questions. If not, that's it for today. Thanks for showing up. Bye-bye for now.